Hello friends, welcome to sitza.com. Now in this video we will learn about aromatic compounds. What are aromatic compounds? The term aromatic, it was first used by Kikuel, which means odor or aroma. Actually, Kikuel first tried to classify the benzene and its derivatives from the known aliphatic compounds, which actually did not have this kind of an order. And basically the benzene and its derivatives have a characteristic smell or an odor which other compounds do not have. So Kikuel used this term to classify those compounds, the benzene and its derivatives, from the aliphatic compounds. But then later on it was associated more about with the chemical behavior rather than with the smell. So compounds which actually resemble with benzene in chemical behavior are aromatic compounds. And we know in a benzene there's alternate single and double bond, right? Double, single, double, and so this is a conjugate system. So that means aromatic compounds, these are also conjugate systems with the alternate single and double bonds. And these compounds generally undergo substitution reactions rather than addition. That means from the benzene you can replace hydrogen by any other group, and these compounds, these aromatic compounds, do not undergo the addition reactions normally, right? Under normal temperature it doesn't undergo the addition reaction because aromatic compounds are very much stable than non-aromatic compounds. So if they undergo addition reaction, if the double bond breaks here and something adds across the double bond, then it will lose its aromaticity, and that requires basically high energy, right? So that means aromatic compounds do not undergo the addition reactions, rather they undergo the substitution reactions, and this behavior is called as aromaticity. This characteristic behavior is called as aromaticity. Now, what are the compounds which are aromatic, right? What is the condition for a compound to be called as an aromatic? Actually, there are three main conditions for a compound to be called as an aromatic, right? Number one is that it should contain a conjugate system, right? It should be, a molecule must be cyclic, and it should be conjugate system, cyclic conjugate system, like the benzene, right? Benzene is cyclic and it is a conjugate system, double, single, double, that's called conjugate system. And second point is that it should be planar, right? That means every atom here should be sp2 hybridized, right? Every carbon atom should be sp2 hybridized. Okay, so the molecule is planar. If it is not a planar, so it will lose its aromaticity. Benzene, we know every carbon is sp2 hybridized, so all the atoms are in plane, so the molecule is flat. It is planar. And the third most important point is that the molecule should obey the Huckel rule. Means the molecule must contain 4n plus 2 pi electrons, right? So the n here can be 0, 1, 2, 3, 4. So for example here, if n is 0, then what should be the 4n plus 2 pi electrons? It is 2, right? 2 pi electrons. That means a molecule with 2 pi electrons is can be aromatic, right? Now if n is 1, in that case you can have 2 into 1 plus 2, so 4 into 1 plus 2, that is 6, right? So 4n plus 2 pi electrons, so it will be 6 pi electrons, right? So that means a molecule with 2 pi electrons is aromatic. A molecule with 6 pi electrons can be aromatic. Similarly, if n is 3, n is 2 here first, so it will be 10 pi electron system, right? If n is 3, then it can be called 14 pi electrons, right? So that means the molecules with 2, 6, 10 and 14 pi electrons can be aromatic. You can see here in the benzene there are three double bonds, which means that it contains 6 pi electrons. So this molecule obeys the Huckel rule, isn't it? So it obeys the Huckel rule because it has 6 pi electrons and 6 is one of them, right? You can see here the possible values there, 2, pi, 10, 14, right? So these are the pi electrons which must be present in a molecule. So benzene, it's conjugate, cyclic, conjugate, it's flat, right? It's planar molecule and contains 4n plus 2 pi electrons. It contains 6 pi electrons, so it is an aromatic. Now what if, a molecule is planar, it is cyclic, it is conjugate also, but it does not have a 4n plus 2 pi electrons. It only contains 4n pi electrons, right? Not 4n plus 2, rather 4n. Okay? The molecule will be called as an anti-aromatic, right? Anti-aromatic compounds. So basically, anti-aromatic and the aromatic, they have a little bit difference. Aromatics, we know their molecule is cyclic, it's conjugate, and it's planar. But here's the difference. Aromatics contain 4n plus 2 pi electrons. Anti-aromatics, they contain only 4n pi electrons, right? So 4n means, it can have a 4 pi electron system is anti-aromatic, right? If n is 2, then it will be 8 pi electron, right? If n is 3, it will be 12 pi electron system. It will be 16 pi electron system, right? That means a molecule which is cyclic conjugate but contains 4n, not 4n plus 2, right? See, if it contains a 4n plus 2 pi electrons, right, then it will be called aromatic. But if it contains only 4n pi electrons, then it is anti-aromatic. That's the difference. Let's take here an example. For example, this is our molecule, cyclobutadiene. This is double bond, single and double bond. Now you can see it contains 4 carbon atoms, 1, 2, 3, 4 here, right? And all these carbon atoms are actually sp2 hybridides. So molecule is cyclic, it is flat, it is conjugate, but it contains how many electrons? There are 2 pi bonds, which means 4 pi electrons, isn't it? So this is actually a 4 pi electron system. It is cyclic, it's planar, but contains 4n pi electrons. So it is anti-aromatic, right? It is anti-aromatic, so it's not an aromatic compound. And what are non-aromatic compounds? For a non-aromatic compound, either of the first two conditions mentioned in the aromatic compounds is not satisfied. We have learned that for a molecule to be aromatic, it should be cyclic. Okay, so if it's not cyclic, then if it is not a cyclic, then it is non-aromatic, right? So here it is, and not a cyclic molecule, not a cyclic system, right? So this is non-aromatic. Or if it is not completely conjugated, right? It is a cyclic, but not completely conjugated here. You can see here, a double, single, double, single, single. From this part, it's not a conjugate system. And in terms of stability, right? In terms of stability, aromatic compounds are most stable, right? Aromatic compounds are most stable. And then the second is non-aromatic, right? Non-aromatic. And then the last one is anti-aromatic. Anti-aromatic or least stable, right? These are least stable compounds. This is the order of stability of these 3 types of compounds: aromatic, non-aromatic and anti-aromatic. And now let's check which among the following compounds is aromatic, right? For aromatic, we know it should contain 4n plus 2 pi electron, right? 4n plus 2 pi electrons, and the values we got 2, 6, 10 and 14 pi electrons, right? A molecule with 2, 6, 10, 14 pi electrons can be aromatic. Now look at the first one here. It contains 4 pi electrons and this is not a complete conjugate system, so therefore this is not a, because in this molecule you find double bond, single, double, and then two double, single bonds here, right? So this is not a complete conjugate system. So we can say this is neither aromatic nor anti-aromatic. Therefore it is non-aromatic. So the molecule is non-aromatic. Here this one, you can see we have a lone pair, and lone pair is also here in conjugation. Lone pair, pi electrons with the nitrogen. So it contains how many pi electrons will be there? Will be 6 pi electrons. So this is a 6 pi electron system, isn't it? And therefore it is aromatic. You can count the lone pair of electrons also there, because in benzene there is delocalization of pi electrons, resonance occurs there. So here also this electron pair can also undergo the resonance, and this is a complete conjugate system here. Now this particular carbon has got a positive charge. It's a cation, right? Cyclopentadienyl cation. Okay, and you can see here this molecule, it contains a 4 pi electron system. This is a 4 pi electron system, and this is conjugate, right? Because this pi electrons, it can undergo resonance and delocalization can occur. Then this positive charge can be delocalized over the whole ring. So delocalization is possible here, right? So this is a conjugate system, and here this molecule is again not an aromatic compound, rather it is anti-aromatic compound, right? This is anti-aromatic compound. And what about this one? Now this carbon contains an electron pair because it has a negative charge there, right? So this negative charge can also be, you can also count it, right, in the electron system here, because the negative charge can also undergo the resonance here. It undergo delocalization, and negative charge can shift to any of the 5 carbon atoms here, and the whole system is under resonance. And this molecule is actually 6 pi electron system, so therefore this is aromatic, right? And what about this one? It's not a aromatic, correct? Because you can see here 2 single bonds there, right? And this will be called as a non-aromatic. This is a non-aromatic compound. Here this molecule, it is aromatic because you got a carbon with a positive charge, and you can undergo, it can undergo resonance, and you can draw the canonical structures for this molecule like this. Okay, we have learned it in the resonance. Okay, and you can draw one more canonical structure if the pi electron shifts in this direction, and then you can have a double bond over here and the positive charge over here. You can see this system is conjugate system, right? This is a conjugate system. The whole ring is a cyclic conjugate system, and it contains 4n plus 2 pi electrons. You can see here the 2 pi electron system can also be a conjugate, an aromatic compound. So 2 pi electron system, so this is aromatic compound, right? And look at this one. Now it contains a negative charge. This particular carbon negative charge, it has got electron pairs available, and same thing that you find here with the positive charge. The negative charge can also undergo the resonance, right? Okay, and you can form different types of resonating structures there, and the system is conjugate, right? It is cyclic, and it contains 4 pi electrons, right? Because this is electron pair, a pi bond, and we also count this electron pair here in the system, in the conjugate system. So it contains 4 pi electrons, right? This is the 4 pi electron system, and 4 pi electron system is not an aromatic, rather it is anti-aromatic, right? It is anti-aromatic compound. Okay, now what about this one? Furan, you can see 2 pi bonds, right? Oxygen with lone pair of electrons, and you can delocalize one of the lone pair of electrons with this pi system here, and therefore it becomes what? 6 pi electrons, right? 6 pi electron system. So resonance is possible there, with the oxygen. Delocalization of the pi electron, so it becomes a 6 pi electron system. So this is aromatic. Okay. In pyridine, there are 3 pi bonds there, right? 3 pi bonds there, and it is a 6 pi electron system. So this is aromatic. What about this one? Cycloheptatriene, 135 triene. You can see double, single, double, single, double, and then 2 single bonds without any positive or negative charge, right? So you can see here this is the carbon which is actually sp3 hybridized, and there are 2 single bonds. So this is not a conjugate system, right? This is not a completely conjugated system. So then it's not an aromatic compound, right? This rather it will be called as a non-aromatic, right? This is non-aromatic compound. Okay. Now what about this one? Cyclooctatetraene. So you can see 1, 2, 3, 4 pi bonds, right? So that means this is a 8 pi electron system, isn't it? This is 8 pi electron system. So it can be what? It can be, you can call it as an anti-aromatic, isn't it? You can say it is anti-aromatic because anti-aromatics contain 4 n pi electrons, and we know the values for the anti-aromatic are, it is 4, 8, 12, 16, right, pi electrons, and here this molecule is 8 pi electrons, so you can say it is anti-aromatic, right? But actually it's not an anti-aromatic. The molecule is not flat, right? Okay, the molecule is not flat. The 4 carbon atoms are in plane. It's just like a tub shape, right? Like this. So since it has, the molecule is not planar, it has lost its planarity, and for an anti-aromatic compound, one of the important conditions for an anti-aromatic compound is that the molecule must be planar, right? It must be planar. It should be cyclic, conjugate, planar, and contains 4 n pi electrons. Then you can call it as anti-aromatic. All the 8 carbon atoms are not in plane, rather it is just like this, and therefore since it has lost the planarity, it will be called as a non-aromatic, right? It is a non-aromatic compound. Now how do we classify the aromatic compounds? Aromatic compounds are classified into 3 main categories: anilines, benzenoid aromatic compounds, and non-benzenoid aromatic compounds. Anilines are monocyclic compounds like the benzene and like this molecule, and these anilines, we write here, benzene will be called as a 6 aniline, right? 6 aniline. 6 here, the number represents actually the number of carbon atoms in the monocyclic ring. This is a cyclic compound, aromatic compound, and contains 6. And here in this molecule, how many carbon atoms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Right, so this will be called as a 14, okay, aniline. And we put the bracket around the number, and this is how we represent the anilines. And then we got the benzenoid aromatic compounds. Benzenoid aromatic compounds, here the benzene rings are fused together, right? Suppose here in the naphthalene, 2 benzene rings fused together to form a 1 molecule. Okay, here anthracene, it contains 3 rings. This is also aromatic, this is also aromatic, but you can see here anilines are monocyclic, and benzenoid aromatic compounds or aromatic compounds where more than 2 benzene rings are fused together. Okay, and then non-benzenoid aromatic compounds. So you can see the azulene is one of the example. It doesn't contain any benzene ring. Rather, it has some different carbon atoms in the ring, and it doesn't resemble even with the with the aniline also, right? So you can see here 1, 2, 3, 4, 5. So there are 5 pi bonds. So that means this is a 10 pi electron system, right? this is a 10 pi electron system, and here in this molecule this is cyclic, it is conjugate, and therefore this is aromatic. Okay, this is aromatic because 10 pi electron system can also be aromatic. Hope you got the concept. Thanks for watching the video. Bye for now.